Check it. I have shared the screen. Screen is visible to you.
Yes, sir, it is
So
visible,
we
sir.
completed till which topic in rotational motion? Last topic.
Sir, we have completed moment of inertia. That's all.
Okay, we only completed moment of inertia. Okay, so let's continue from the after the moment
Sir,
of
I
inertia
think
talk.
we skipped
Huh.
a collision topic. Sir.
Collision we skipped.
Yes, sir.
Okay, we will do collision after completing this. So,
Yes, sir, it is.
or when required, then we will do. Okay, so, okay, so torque we did or not?
Sir, talk not. So only definition you said, sir.
Okay, so after the moment of radius of gyration we have done.
Sir, there is also not there. Only moment of inertia problems on that.
Okay,
How to?
so let's start after moment of inertia. Let's start with the radius of gyration. So here you can see a screen is visible to you.
Yes, sir, screen is visible, sir. No issues.
Okay, 1 minute. Here you can see that if a rigid body is there, then that rigid body will have some moment of inertia about a given axis. So you can see here that I am drawing now. So if this is a body, this is a body of any irregular shape and size, and this body will have some moment of inertia about this axis. Okay, let's take that the total mass of the body is given as m. Total mass of the body is given as m, and this body has some moment of inertia about this axis of rotation that we are calling as I. Okay, I. Now, what is radius of gyration? Radius of gyration says that in place of this whole body, can we replace this whole body with a point mass where whole mass of the body is concentrated so that the moment of inertia of that point mass comes exactly same as the moment of inertia of this body. So this is a rigid body, any shape and size. This is the body, and about this axis, this body has some moment of
Sir,
inertia.
the
Let's
screen
call
is
that
not visible, sir.
not visible now.
Yes, sir, not visible, sir.
Okay,
Black
1 minute.
on. Yes, sir.
1 minute.
Yes, sir.
Now check. Now visible.
Sir, now also not visible. Black on the side.
Only black. Why is this happening? You rejoin. Try to rejoin or
So
refresh.
I'm rejoining, so 1 minute. Sir. Yes.
Okay.
Sir, now it's visible, sir. Now it is.
Okay, so here you can see that a body is there of mass m, and the moment of inertia of this body about the given axis is I. Now we can do one thing, that about the same axis of rotation, you know, we can replace this whole body by a point mass. in such a way that the moment of inertia of this point mass, where whole mass of this body is concentrated, है ना? So moment of inertia of this point mass comes out to be exactly same as the moment of inertia of this body. So moment of inertia of body about the axis was I. So moment of inertia of this point mass about the axis should be also I. Okay. So the distance at which this point mass is kept so that you get moment of inertia exactly same as the moment of inertia of the body, that distance is called as the radius of gyration. So here you know that if I is the moment of inertia of this body, and here the body is replaced by a point mass, and we know that moment of inertia of point mass is simply mr square. So m into perpendicular distance square. That perpendicular distance is nothing but k. So I equal to mk square. Okay. Now here what is k? K is the radius of, called as radius of gyration. For example, if suppose this is a sphere of, let's say, radius r, and let's say mass of this sphere is m. Okay. And I'm taking one axis which is passing through center of this sphere. Okay. Now what is radius of gyration of this sphere about this axis? So radius of gyration is simply the perpendicular distance at which I can place a point mass whose mass is exactly same as the total mass of this sphere, so that the moment of inertia of this point mass about the axis comes out to be exactly same as the moment of inertia of this sphere about the axis. Moment of inertia of the sphere about the axis, you already know its value, that it is 2 by 5 mr square.
Sir, sir, point mass means the mass. Uh,
Point mass means the mass is just concentrated at a point. Whole
means a
mass is
body with
concentrated.
no dimensions we can consider.
No dimension, yes, no size, yes.
Yes.
Now, if this body is placed at some perpendicular distance, let's say k, and it is a point mass. So for point mass, we already know the formula is m into perpendicular distance square. That perpendicular distance is here called as radius of gyration. So it is mk square. Now this I and this I are exactly same. So I can write now that mk square is equal to 2 by 5 mr square. So mk square is equal to I, and I we already know about this axis is 2 by 5 mr square. Now comparing it, we can find k. So here you can see I can cancel I m both side, and then k I will get as root under 2 by 5 r will come outside by 5 r. So if you replace this whole sphere by a point mass kept at a perpendicular distance of this root 2 by 5 r, then the moment of inertia of this point mass about the axis will be exactly same as the moment of inertia of this sphere about the axis. That's why this distance k is called as radius of gyration of the sphere. Are you getting?
So means radius of curvature means it's a distance
It is
where
just a
point.
distance where you can replace this whole body by a point mass of having exactly same mass as that of the whole body, so that moment of inertia comes out to be exactly equal.
Yes,
Okay. So if you want, you can write. I'll go to the next then. Can we go to
sir,
next?
we can go.
Okay. So then let's go to the next now. So this is the radius of gyration. Now you can directly also write down the formula of the radius of gyration. So because I is equal to mk square, So K will be root under I by M, where I is moment of inertia of this body about the axis. So if you know the moment of inertia of a whole body about an axis, and you know the total mass of the body, then you can find radius of gyration for that body by using this formula K equal to under root I by M. Okay, let's go to the next. Now here you have this question. You can try this quickly. So just try this question quickly. It is already asked in JEE mains exam. Question is visible to you?
Sir, question is
Okay, just do it fast, quickly. You can ask your
sir,
doubt if,
it is root 5 by 3 r.
root 5 by 3 r you are getting. So that is correct. Root 5 by 3 r is the correct answer. Okay, so let's go to the next. Now the next is moment of inertia of a body having a cavity. If a body has some cavity, then how to find the moment of inertia of such body? So that is very easy. You can see here that suppose this is a body and the body will be of any shape and anything. I am taking just like a, I'm just discussing the concept here. So any body is there and this is the axis. Okay. And from this body, some part is cut and removed. So some part of the body somewhere is just cut and removed. So I have cut suppose this part and removed. You know? Suppose this is a spherical part which I have cut and removed. And the bigger one is also a sphere. So inside the sphere there is a cavity. So this part is cut and removed. So in this part there is nothing. No mass is there because this is hollow, cut part. Okay. Now we have to find moment of inertia of this remaining body. Means after cutting, what is the moment of inertia? So moment of inertia after cutting will be first of all moment of inertia of the whole body about the axis minus the moment of inertia of the removed part of the removed part. So I am writing removed. Yeah, or simply I can write I cut the cut part. So cut part. But the problem here is that both the moment of inertia of the whole body and the moment of inertia of the cut part, you have to find about the same axis. Are you getting? Moment of inertia of the cut part, you don't have to find about this axis. You have to find about this main axis. So moment of inertia of this whole body first you will find, means before cutting, and then from that you will subtract the moment of inertia of cut part. But moment of inertia of the cut part should be also about the main axis, and moment of inertia of the whole body should be also about the main axis. This is the main axis. Are you getting it?
It's given axis.
About the given axis, yeah,
Yes.
means whatever axis is asked in the
We
question.
are finding that axis.
Yes. So all I should be about the same axis. Okay. So You can just try this question here from this concept. This is asked in JEE Advanced exam. So can I start with this question? Question is visible to you?
Question is visible, so not.
And yeah, 1 minute. So, and in the question, there is a diagram given. So I am adding that diagram also. So this is the diagram, question and diagram. Try. Try it quickly, roughly on your notebook. Just draw the diagram. Read the question, what you have to find, and just do it quickly. To find the moment of inertia of cut part about the given axis, you may have to use parallel axis theorem or perpendicular axis theorem, but I don't think any theorem. Maybe there will be use of that. So try. Also, you should be careful that when you are calculating the moment of inertia of the whole body before cutting, then in that situation you will take the mass of whole body before cutting. Many a time in the question, mass of the body after cutting is given. That mass if you use, it will be wrong. Do it fast. Try to do it fast.
So here we need to use perpendicular axis theorem, sir, to find the center of the amount.
So find the moment of inertia of surgery relative to the axis passing through the geometrical center and perpendicular to plane of the yes. So no, but yeah, perpendicular to plane of the disc. But then I think you will have to use parallel axis theorem. Means both perpendicular also, parallel also. You try, and then you
Yes,
can
sir.
ask your doubt.
I'm trying to verify this. Radius R by 30 pieces. The mouse disk equals total mass of this system. Directly the mass of the the mass of the disk means here we need to consider as whole disk or the disk remaining after removing that r by 3 radius disk.
No, so you understand that, when you will find moment of inertia of the whole disk, you have to take mass of the whole disk, and from that you will subtract the moment of inertia of the cut part. So for that you have to take mass of only the cut part.
So not sir. In the question he mentioned the mass of the disk is equals to m. Sir. This is the mass of the disk after removal or
Okay,
before
1 minute.
removal. Sir.
A uniform disk of radius this has a round cut of this as shown. The mass of the disk equals m's. Find the moment of inertia of such a disk related to the axis through geometrical center of the original disk. So I think it is mass after cut.
Yes, sir.
It is mass after cut, because first line is saying that a uniform disk of radius r by 3 is cut as shown in the figure. So first of all it is cut, and then after that they are saying mass of the disk equals m. So I think it is after cut. So it depends on the language how they present it.
Sir, we can first we can consider the mass of the disk. If you consider the total mass of disk as m1, sir,
Hmm.
and this removed mass is m2, we can write m as m1 minus m2.
Correct.
That's now I'm going to find the
A
mass
relationship
of
between m1 and
yes,
m2 you can find because you know their radius.
yes, sir.
Yes.
So we can find the value of sigma also, like mass.
Sigma, yes. And then you can do sigma into area.
Yes, sir. After that, we can write an IM, sir. The
Yes.
moment of inertia will hold.
Yes.
And by substituting the value of sigma, we get the answer
Yeah,
of the
correct.
moment of inertia.
So no need to find the mass. See, sigma of the whole will be same sigma.
Yes, sir.
For the disk also same, and for the cut part also same sigma. So simply in terms of sigma, you write down the mass. So
Yes, sir. Understood. Yes. Then by
yeah.
substituting, we can get the value, a moment of inertia
Yes.
of the disk.
Yes. Okay. So you want to go to next?
Yes, sir. We can go. Sir.
Okay. So then let's go to the next here. And now we are introducing torque. Okay. So first of all, you have to understand that what is torque. Torque is defined as the turning effect produced by the force. So for example, a door is there, and when you apply force on the door, door starts turning, rotating. So that turning effect, which is produced due to force, that is called as torque. And this turning effect produced by the force depends on two things. First is the force, and second is that where is the force applied, and third you can say that the angle between the force vector and r vectors. For example, suppose this is there is a particle here. You can say this is the particle, and on this particle a force is applied. You can see the force is applied in this direction. This is the direction in which the force is applied. This is the direction. In this direction force is applied on the particle. Okay. And you have to find what will be the moment of inertia, sorry, what will be the torque due to this force about this point. So first of all, force is acting here on the particle. Okay. Force is acting on the particle. This is F vector. Okay. And you have to find the torque about another point O. So now first of all we define a vector joining the point O and the point where the force is acting. This vector is called as vector R. Okay, vector R. And now if you do the cross product of this vector R and the vector F, you know, so then you will get the torque of force F about the point O, R cross F. This is the how it is defined. So because it is cross product of two vector, it will be also a vector. So torque is a vector. Direction of torque will be perpendicular to the plane containing R vector and F vector. It is like this. Suppose if this is I have taken as x-axis and this I have taken as y-axis, and in this xy plane there is a particle somewhere here, and on this particle some force starts acting in this direction, or to get a feel you can consider that this is the particle of a rod, and the rod is like this. A rod is like this. This is a particle of a rod, and the rod is like this, suppose. Okay, and the rod is hinged about this origin here, about hinged here, and on this rod a force is applied here. So force is applied here. Okay, now here you can see that the force will this force will try to rotate this rod about the this point, about point O. It will rotate, so it will rotate like this about this. Means this force is producing some turning effect in the rod, and the rod starts turning about the point O. Now we have to find the torque due to this force about point O. So then the torque is simply defined as, torque about a point first of all. So torque not about the axis, torque about a point, about O, is simply called as R cross F. So R vector cross F vector, R vector cross F vector. And this is the torque due to this force about the point O. Okay. And what is R vector? So R vector is simply a vector joining the point where you have to find the torque to the point of application of force. Force is acting about this point. Let's call this point as point P. So O to P, joining vector is vector R, and another is the force vector. You just take their cross product and you will get the torque about point O. And that torque may be in any direction depending on what is the direction of the force. Force may be in the plane of this xy plane, or maybe in not in xy plane. Are you getting?
Sir,
But
I'm getting.
but the torque will be always perpendicular to both the r vector and the f vector. Means torque vector will be perpendicular to the plane containing r vector and f vector.
Sir, torque plays same role of as force in translator motion, sir.
So in that way you can say, because in translational motion force produces an acceleration, and that acceleration is translational acceleration, and here you will see that torque produces angular acceleration. So yes, it plays the same role. Now if you want to find the magnitude, so magnitude will be simply magnitude of r cross f, that will be rf sine theta. Okay, there is another simple way to directly calculate the torque, so this is a point where you have to find the torque, and force is acting on the particle here in this direction. So this is clearly the direction of the force vector. This is a force vector which is in this direction. Okay, and what is r vector? R vector is simply vector joining the point where you have to find torque to the point where the force is acting. So this is r vector. Now you can do r vector cross f vector. That will give you the torque about point O. But you know, if you only want to find the magnitude, not the vector, magnitude, then you can simply do one thing. You can simply multiply r perpendicular with f, because rf sine theta you can write as r sine theta into f, and that r sine theta will simply give you a perpendicular distance between the line of action of force. So force is acting along this line. This line is called as line of action of force. You can see this yellow line, and we can make it dotted. This dotted line represents the line along which force is acting. This is called as line of action of force. And if you drop a perpendicular from point O on this line, this perpendicular will become is called as r perpendicular. Why it is called as r perpendicular? Because it is perpendicular to the line of action of force. Here you have to understand that where is theta. So if you just extend this line slightly, r vector is in this direction. This is the direction of r vector. What will be theta? Theta is simply an angle between r vector and f vectors. That angle is nothing but this angle, theta. You can see this angle is theta between r vector and f vector. If this is theta, then vertically opposite, this angle will be also theta. Now in this triangle you can go. You can see this triangle. In this triangle you can go. And you will see that r perpendicular will be nothing but r sine theta, right? In this triangle. So rf sine theta. So r sine theta is nothing but this r perpendicular. That's why the formula simply can be written as r perpendicular into f, which is nothing but rf sine theta. Many a time drawing this r perpendicular is very easy. Calculating this r perpendicular is very easy. Are you getting it? You have any doubt?
Sir, no, no doubt, sir.
Okay, so then I'm going to the next. So let's go to the next now. Now you can try this question.
Sir, perpendicular distance is the perpendicular from the axis to that point always.
Not axis, first of all. You know? Not maybe there is axis, maybe there is no axis. There is just a point. Till now we have not discussed about the torque about an axis. Not discussed. We have only discussed torque about a point. And maybe torque about a point is not along the axis. We will also discuss how to find torque along an axis. But till now we have only discussed torque about a point. See in this question, they are simply asking you find the torque about a point. Torque about a point is just about a point, not about an axis, right? Try this question now. So in this question, it is not shown. They should write here that this represents F vector, force vector. And this force vector is acting about this point here. Coordinates of that point is given. And you have to find torque about the origin. Oh, do it. This question already came in JEE Mains exam. Hmm.
Point two. At least would be one by one for the uncheck is okay. In force vector. Oh, not force vector. Sir, he mentioned force or not given or not.
Sorry.
The
Okay, one
force
minute.
value
I
is
think,
not
yeah,
given.
I think 1 minute. Let me check. Yeah, I think they forgot to give in the question. So force vector is this one. I will show you. This is the force vector. Can you see this?
Is I can see sir, this 5 root 3 I cap plus 1.
Hmm. This is force vector that you have to use here.
I cap plus 4 plus 5 root 3 I cap plus 5. Now we will find cap, 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 cap,
Tell me, are you getting? Not getting?
sir, I'm calculating the transport.
Okay.
Sir, about point also, we get 5 minus 5 root 6
Hmm.
k capsule.
Hmm.
About
So
point A, we get minus 5 root 3 k capsule.
minus 5 root 3 k cap is the correct answer. Okay. So again, you can try this one. Try this question. Here you can directly use R perpendicular into F.
Yes. So due to minus mg x k cap minus m
Okay, minus mg
x k cap x not x.
minus mg x naught k cap, that is the correct answer. Now we are going to talk about the torque about an axis. Till now we were talking about torque about a point. Now we will talk about torque about an axis. So now suppose axis will come for fixed bodies which are fixed to rotate about fixed body in the sense that it can only rotate about an axis. So for example, if this is the body and the body can rotate about this axis, so it is not free, the body is hinged about this axis, means it can rotate about this axis. Now in this situation, if you apply any force on the body and think in 3D, means you are applying a force not on the screen perpendicular to the, are you getting like this, on the body, on this 3D body, this force is not on the screen, is perpendicular to the plane of the body, you can say, or plane of the screen, you can say. So if you apply a force like this, the body will start rotating about the axis. Okay, this is the axis. Now you have to find what is the torque due to this force about the axis, not about any point, about the axis. To calculate the torque about an axis, first of all, you select a single point on the axis, anywhere on the axis, anywhere. So I am selecting a point on the axis here. Anywhere on the axis, you can select a point. And then from this point, I will draw a R vector. Now I have R vector and I have F vector. Now you clearly know that dot product of R vector and F vector will give you a torque about this point, not about the axis. So torque about the point first I will calculate. So I will calculate torque about O, and torque about O will be R cross F in vector form. So vector R cross vector F. Now depending on, in 3D you can imagine F can be in any direction. The body is a 3D body. F can be in any direction. Torque about O will be always perpendicular to R vector and F vector. Here you have to understand that the direction of torque about the point O is not necessarily that it will come along the axis. It may come along the axis, may not come along the axis. But we have to find torque about the axis. So how to find torque about the axis? So first we selected a point on the axis and we calculated torque about that point. But now we have to find torque about the axis. Torque about the axis will be simply the component of this torque about the axis. So torque about point O will be in any direction, but then we can take its component along the axis. That will be the torque about the axis. How to take component of this torque vector about the axis? So you simply do the dot product of this torque vector about point O with n cap, where what is n cap? N cap is a unit vector along the axis. N cap is a unit vector along the axis.
Yes.
So you can write here n cap is a unit vector along the axis. Suppose the axis is along x-axis, then in place of n cap we can directly write I cap, because I cap is nothing but a unit vector along x-axis. If axis is along y-axis, then we can write torque vector dot j cap. So torque about an axis is simply the component of the torque which comes along the axis.
Yes. Hello, sir.
Yes, tell me. Are you getting?
So I'm getting.
Hmm. Okay, so then let's go to the next. Now, here you have to understand that if the line of action of force is parallel to the axis, then always torque about the axis will become zero. Because if the force will be parallel to the axis, then r cross f will become perpendicular to the axis. And if r cross f will become perpendicular to the axis, then it will have no component along the axis. Are you getting?
So means the component of torque in different direction we are saying the torque in that axis we can say. So
Yeah, so axis will be given in the question. So about the given axis, you have to take the component. First, you have to find r cross f, and then you have to take component about the given axis.
so means uh,
Hmm.
every component of torque is in torque in that particular axis we can say. No?
No. For example, suppose so torque vector can be in any direction, and if it can be in any direction, then it will have only one component along the axis, and it will have another component which will be another components which are not along the axis, which are perpendicular to the axis.
Means you can that is along that axis it's a torque
For
we can say. No?
example, yeah. So for example, if this is the if this is suppose the axis, and the torque, if you imagine in 3D, then you can is coming out of the screen. Are you getting out of the screen? Torque is in this direction, coming out of the screen. Then it will have three components now. One component along this direction, but only one component along the axis, because axis is just a line now. So a vector have only one component about a line. Other components will be perpendicular to this line. Are you getting? So if it is making, let's say, some angle alpha with the axis, torque vector, and this is axis, this is axis, this one, and this is the direction of torque vector, which is not on the screen. Imagine it in any direction, coming out of the screen or going into the screen, any direction, any general direction you can imagine. So its component along the axis will be this vector, which is nothing but, you can find it by doing
So generally
torque vector dot product with n cap, unit where n cap is unit vector along the axis. Yes, tell me.
so the general torque will be so if you take an axis it will be perpendicular so maybe if you take y-axis as an axis
Okay.
if your body is rotating in x-y plane so then torque will be in z
Then
axis.
automatically, yeah. So then automatically, yeah. Then torque will come in z axis.
Then how can we then we cannot make components also. Even if it will be
Yeah,
zero,
so
sir.
then the component will be zero about the axis.
So every time either axis means okay, sir, anything.
So torque can be in any direction depending on what is the direction of the force. Force can be in this direction, in this direction, in this direction, coming out of the screen, going into the screen. Are you getting?
Yes, sir, I'm
You
getting
have
sir
to
now.
think in 3D. So depending on that, torque will be in any direction, but you have to always take component of torque about the axis. If component of torque about the axis is not coming zero, then it is zero. Means if torque is coming in this direction, perpendicular to the axis, then it means that
So
component
when
torque
here we
about the
can
axis
see,
is zero. If suppose torque vector is in this direction, perpendicular to the axis, okay, then what is the torque about the axis? Torque about the axis is zero.
so we can
Yeah.
so we can define means we can say we can define the tag about an axis if the axis is inclined at some angle much other than 90.
No, no, no. Axis can be uh, any in any direction. Means if suppose it is not 90, this is the axis. Suppose this is the axis, and it is not inclined at 90. It is inclined at suppose let's say here only at some angle theta, which is less than 90. Then also we can find torque about this axis, and then we will say torque about this axis will be simply the component of this torque about the axis. How to calculate it? Torque vector dot n cap, where n cap is unit vector along the axis. Here also you calculate it by the same logic. Here also you got 0 by calculating torque vector dot n cap, because torque vector is in j cap and n cap is in x cap. So j cap dot I cap n cap है ना, is become 0. Are you getting? Always only one formula. Torque vector, its dot product with a unit vector along the axis. An axis can be in any direction and torque can be in any direction. No condition. Keep asking your doubt.
Sir, I'm not getting three-dimensional exact clarification.
Yeah. So, for example, suppose this is a body, 3D body, and this is the axis. This is the axis here. Okay. Let's take the axis is along the y-axis, vertical. Now, suppose that a force is acting on this body in this direction. The force is also along y-axis, parallel to y-axis, negative y, like this. This is the direction of force. Now, in this case, what will be the direction of the torque? What will be the torque about the axis? So to calculate torque about the axis, first you take any point on the axis, and from that any point on the axis, join this point where the force is acting. This vector you call as r vector. So you got r vector and f vector is already given. Now you know that torque about this point on the axis will be perpendicular to r vector and f vector.
Yes.
Now here you can see that f vector is parallel to the axis and torque vector is perpendicular to r and f, means the torque vector in this situation will be also perpendicular to the axis, right?
Yes, sir.
Torque vector will be also perpendicular. Imagine in 3D, this is coming out of the board, perpendicular to the
Yes,
axis
towards us. Okay.
and going this backside also. Okay. So now here in this case, if you see the torque will come in this side, going away from yourself. perpendicular to the axis. This is the torque vector. Now clearly you can see that this torque vector is perpendicular to the axis. So then what is torque due to this force about the axis? Torque about the axis is zero,
Yes.
because this torque vector has no component about the axis. That's why zero.
Sir, generally, if we say torque in this particular direction, what is this? What is its meaning? Sir, means the rotation is in that direction. Means
No, there is no rotation in the direction of the torque.
just
Rotation, a torque direction is always perpendicular to the plane of rotation.
sir means just by formula we are when you define, so we are defining the direction like this. Sir.
Yeah. So all the angular variables are defined in the in terms of the direction perpendicular to the plane of the motion. So torque vector also, its direction is perpendicular to the plane of rotation. So torque vector will come out in the direction of the angular acceleration. Direction of angular acceleration is also perpendicular to the plane of rotation. So direction of torque vector should also come in the direction of the perpendicular to the plane of rotation. In the plane of rotation, there will be no vector direction. Means no vector direction means no angular variable vector direction. Means torque vector, omega vector, alpha vector, theta vector, all these will be perpendicular to the plane of rotation. Keep asking.
So even we are defining all this uh, perpendicular to the most plane of motion, sir. But
Yeah.
actually the means just because we define formulas like that, we are defining this direction. So, so when in present this is that in this direction there will be some change in momentum like that. Like that we cannot define anything in this direction physically.
Not getting.
Sir, means so generally we say that
You can
angular
take any
velocity is
example. Yeah.
the angular velocity rate of change of angular displacement. Also.
Yes.
So angular displacement will be in the body in the direction of rotation also.
No. Angular displacement
Yes,
direction is
fine.
perpendicular to the plane of rotation.
Sir, but yes, sir, it is perpendicular, but it actually the body is moving in that plane only, no, sir. Why we are different? That's thing I'm not
Yeah, so body is, when you are saying body is moving in the plane, so in the plane there is linear, all the linear are defined in the plane. Linear displacement, linear velocity, linear acceleration of the body. So same body has linear velocity also. Linear particle. Every particle has linear velocity. You know. Actually, angular is defined perpendicular because body is not going from one place to another place. Body is just changing its orientation. For example, ceiling fan is not going from one room to another room. Ceiling fan is just changing its orientation. So because the ceiling fan is not going from one place to another place, how can we say that its direction will be from in the plane? So it is just changing orientation. It is rotating like this, changing orientation. So it is defined in such a way in plane perpendicular to the, because that is the only unique direction. In the plane you cannot define the direction. Tell me how you will define the direction in the plane. And in the plane there are multiple direction. Now tell me which direction you will define. There is no unique direction. Are you getting? In the plane
Yes, sir.
there is no direction in the plane. This is direction, this is another direction, this is another direction. All directions are different, but the angular displacement or angular velocity or angular acceleration of the fan is only in one direction. So which direction in the plane you will choose? There is no unique direction. But perpendicular to the plane is a unique direction. That's why that is chosen. Also perpendicular to the plane, there will be two direction. Out of those two direction, one direction is selected
Right
according to
hand.
the right hand thumb rule. Yes.
Um,
Okay. So now let's go to the next. So now you can try this question. Try this question. So there is just a sphere which is you can say rolling or is at rest or something like that. Is rolling you can take on the inclined plane. Now you have to find torque of the weight of this sphere about the point of contact. P is the point of contact of the sphere with the inclined plane. About
then
that
we
point,
can directly use formula also because the point of
yes, directly use formula. So use it in this situation. See, M is given, R is the radius of the sphere, that is given. Theta is the
then
angle made
MGR
by
sin
the,
theta will be the answer.
sorry,
And MGR sin theta will be the torque about the point P due to weight we can say.
yeah, so MGR sin theta you are saying. So first of all, MG will be in 1 minute. MG will be in this direction, okay, and this is R.
Theta S. Then R sin theta will be perpendicular distance. Directly for formula.
This is R. This is R, okay, and then you are saying that R. I will take R sine
Sin
theta.
theta component
From
will be
here you
perpendicular.
will. Okay, so that is correct. MGR sine theta. Yes. So directly like this you will do MGR sine theta. Okay, that is correct. Now you can go for this question. This again came in JE Advanced. You can try this question. Try this question. So here you can see a bob is suspended by a string from point O, and the bob is moving in horizontal circle. Means this is like a conical pendulum, right? Means here is the bob, and the bob is moving in a circle of radius r, horizontal circle. And this is the string. See where the string is connected, about point O. A string is connected, so a string will be exerting some tension force on the bob. Now they are asking the torque of gravity and tension about point O and O dash. Now this is this is O, and this point is O dash. So O dash is the center of the circle in which the bob is moving. This is O dash. This is center of the circle in which the bob is moving, and O is the point of suspension of the bob from which a string is connected. Understood?
Sir, understood, sir.
Length of the string is L and radius of the circle is R, small r. And forget this Y. This is not important here. So first of all, you have to find point about point O. And then you can find about O dash.
What is a conical pendulum, sir?
Yeah, tell me. What is?
Generally meant by conical pendulum.
Conical pendulum is simply a bob connected by a string, a small mass connected by a string, and the mass is moving in a horizontal circle. So in that case, the string rotates and forms a cone-like shape. A string. If you look at the string, it is forming a cone. This arrangement is simply called as conical pendulum. When the bob moves in a circle, if you look at the string moves forms a cone here. You can ask your doubts.
Sir, I understood.
Okay, so then solve it.
Question is not visible, sir.
Hmm.
Sir, question is again not visible.
Sorry, not visible.
Not visible. That's
So 1 minute.